My name is Kendall Queen. I'm a fourth-year PhD student under the advisement of Kostas Danilidis in the GRASP Lab. So the demo that I plan to do and show off today is showing that the camera that we have, the neuromorphic event camera, it can sense the world a little bit different than traditional cameras. So I'll show how that works in the real world and how that compares to traditional frame-based cameras and how it relates to the way that humans actually sense the world around them. Then I will show that camera working on my robot, Ryder. Traditional cameras work by capturing what's in the scene, so what's in the resolution of the camera, what the pixels see. And then you capture all of that at one time, and that's what we call a frame. So that would be what we would consider a picture. In order to make a video, you take a lot of these pictures at smaller time intervals, at less time, and then you put them all together, and that becomes what we see as a video. The way that the human eye works is that when light comes in to our retina, it interacts with the cones and rods, and those electrical signals stimulate our brain in a way where we are able to visualize what we see. Ryder is a 10th scale Traxxas RC car. We took out a lot of the electronics that came with the vehicle and then put in our own. So we have an advanced motor controller. We have a brushless motor to help the wheels go. The brain of Ryder is a NVIDIA TX2, which is a mini computer that you could also buy closer to a couple $100s. But all in all, Ryder costs somewhere between $9,000 and $10,000. I think high school me would be beyond the moon to look at myself and be like, yo, you work on robots. Like, that's what I want to do, but how'd you even get there? I think that was probably the biggest question I would have at that time. I remember months before I went to college is when I met the first Black PhD in engineering that I've ever met. And I know to do a callback, the first question I asked him is, what is the best avenue that I could take to do robotics? I remember that was my first question. And he said, based on the places that you are, make sure you come here, be a Meyerhoff scholar, and do electrical engineering. Penn is just like such an amazing place to do robotics. Indoors, outdoors, there's just so many interesting things that are happening, in reference to being a part of the GRASP Lab and being in the School of Engineering. The main GRASP Lab is the first place. We have a good amount of space to just kind of run some things. And when I was first doing experiments with Ryder, I was using a rope, and I used that rope as like a lane line, and I was using that to kind of follow within the GRASP Lab. And I laid out a little track and did some testing there first. One of the biggest differences that my work wants to exploit between event cameras and traditional cameras is how we interact with the information, or how the information is transmitted to us. So for a camera, the pixels work together synchronously. And that basically means that when we want to capture an image, we use all of the pixels together, and they are all captured at the same time. So they are in sync. On the other hand, when you're using event cameras, each pixel interacts independently of each other, which means that they do their own thing. So they transmit data to our computer by themselves, independently. We also call that asynchronously. So you want to be able to capture as much information as possible in that time frame. With traditional cameras, it could be a little more difficult to do so, or more expensive. Once you have your information and your data of the environment that you are seeing, then you have to bring it in and do something with it. So inside your brain or inside the computer, you have to make some decisions. If your task is to recognize things in the room, the fastest way and the best way that we know currently to do that is to use neural networks. Even though the majority of the field of computer vision uses neural networks in the problems that they solve, I am not using neural networks currently on Ryder. I am using what we call a first principle approach. More simply put, I'm using traditional computer vision algorithms. One of the most important algorithms that we use is the Huff line transform. Now, the Huff transform is a very popular technique that can detect any shape that you can represent in a mathematical formula. In our work, we're trying to detect lines, which means that we use the traditional y equals mx plus b to determine the shape that we want to find. Another technique that we use is k-means clustering. K-means clustering is an algorithm that focuses on breaking apart our data into specific sections. So like the Huff transform is like, okay, well, this seems like a line, this seems like a line, this seems like a line, and you'll get a whole bunch that follow the trajectory of like what's there. So I cluster them, all of it, and I break it into two pieces. And the algorithm does its own little sorting, and it allows me to say, all right, this is the left side of the line, this is the right side of the line. Now, what's the average? And then draw it. And that's where you get two lines from. So we have two lines in the lane, right, that you run in. We are saying that we can find the left and right side of that right lane line. So once we have the right lane line, I wanted to detect the left side of it and the right side of it, which is what we see here corresponded to red and green. Netflix recently came out with a show called Lost in Space. It's based on the movie that actually came out like decades ago. And I saw that movie like I was really young. And besides like a scary part that I thought was horrifying at my age, when I first met like that robot, and he's like, oh, Will Robinson, danger, Will Robinson, danger.
Danger. I'm in no danger.
That like opened my eyes to the fact like, yo, robots could be like your friend or like help you with tasks. Like it really changed my perspective. And I started to realize that not only did I like robots, but I also like working with my hands. I used Legos. I started building like little model structures. I used to do model cars. I would build them, I'd paint them, I'd put them all together. And that started to foster my excitement for using my hands to what I now know is engineering, and also using my mind to kind of solve the puzzles that came with those activities. You're gonna hear that you have like all the time in the world, and it's true, but for those that are in high school, you're capable of being the next generation of scientists or the next generation of engineers.